So we've seen how all of these models within APO work. We've been able to model them with Excel, and you had a chance to play around with all the different parameters, and hopefully you have a better understanding of how they work. Now we're going to get outside of just these types of models into a more general view, and we're going to talk about explicative versus predictive models. Time series models lie within the realm of what we call the predictive models. Why is this? Because seasonality, for example, which is explained through cycles within these models, can be predicted, but there's no causal explanation within the model itself. So seasonality is there because of a reason. Could be temperature, could be something else as well. And the model is not trying to understand the relationship between the variables. That's why it's just a predictive model. It's just looking at patterns and trying to mimic those patterns. So that's what a predictive model does, right? On the other hand, you have explicative models, which are trying to understand the relationship between the variables, and it's not just about the predictive experience that you can get or the predictive values that you can get, but it's more about the explanation that you can get from these coefficients and from these relationships, which will allow you to generate scenarios. You cannot generate scenarios with the time series model, because scenarios is about changing assumptions, and the predictive models do not have time series models do not have any assumptions of other types of variables in them. But with explicative models, with causal models, you have that ability. So let's look at about the comparison between explicative and predictive models. First, the model structure, we talked about this. In explicative models, you want something that makes sense, because if it doesn't make sense, then it's not explaining things correctly. In predictive models, it doesn't matter that much necessarily, you just want accuracy. Let's talk about validation, and this will give us some side thing to explain. We are talking about here ex post and ex ante values. What are we talking about with this? So we look at something like forecast accuracy metrics. There's two periods in time where you can measure forecast accuracy, and they're completely different. If you have your time series, that looks something like this, and then in the future it looks something like this, then what you're gonna have is, for example, a model that tries to adapt and generates a forecast that also tries to continue with that adaptation, right? So what is ex post and what is ex ante? Ex post is the adjustment of a model to actual data, right? So for generating this red model here, we actually used all the data that we have over here. So the model knows the data, and it's going to be able to adjust that as long as you have the parameters and the coefficients to adjust to that data. You can measure forecast accuracy in that space, but it's not going to be a predictive forecast accuracy, because again, the model used that data in order to generate those values. So this is what we call an ex post measure. When you, in the end, forecast, which is the blue line which you have here, and that you wait for reality, or you have another data set that you never used, which is the dotted black series, and you compare them and you measure forecast accuracy there, then there you're using an ex ante measure, and that is predictive measure. Okay, so ex post looks at adjustment, and it's good to understand whether the model is able to adjust to a set of data, but the blue thing is that we care about in-demand forecasting, which is the ability to predict. So always, whenever you do an experiment, whether you have an explicative or predictive model, in the end you have to do a test for ex ante forecast accuracy. Okay. So the focus in explicative models is the coefficients, and basically you cannot have a model that says that if you higher price, then you're going to higher volume, then volume is going to go up, because it doesn't make sense, right? So coefficients need to make sense. And in predictive models, you're looking for something that's simple and that you can reproduce in time. Again, this falls back into the objectivity that we talked about in the different introduction. In explicative models, we're looking about significance, statistical significance, and the relationship is good, and that's okay. Even though you have a good predictive value or not, what we're looking about is significance, and we're going to talk more about that in causal models. Instead, in predictive models, you're talking about precision. And now, of course, if you have a good predictive model, then there's basically an explicative component in there, and vice versa. If you have a good explicative model, then you have a good predictive model as well. But believe me, there's a trade-off in each one of them, and you need to understand what you're looking for, what you want to do with the model, and then which method do you use, because there are predictive methods and there are explicative methods. The time series methods that we have that we've just seen, are predictive methods, purely predictive methods.